this session, introduction to, all right, thank you very much for your excitement. Now, screen, and then there we are. Okay, if you can see the introduction to IMR chart from last time, just type, if you can see that, type yes in the chat box, introduction to IMR chart. Just want to make sure that on the right screen. Good, okay. Okay, so IMR chart is individual moving range. Okay, now whenever we have a data, we want to make sure, let us say we are producing a piece of automobile component, we want the diameter. We want to make sure that the diameter, if it is 10 millimeter plus or minus 1 millimeter, we want it exactly within that specification limit. Okay. So the specification limits are decided by the customer. There is an upper specification limit. There is a lower specification limit. Any product has got certain characteristic, for example, weight, diameter, etc., length, etc. So it has to be within that specification. Okay. So all of you type USL and LSL for upper specification limit and lower specification limit. Okay, now, since you have this upper specification limit and lower specification limit, we want to make sure that the parameters what we are measuring is within these specification limits. Now, at this point in time, I want to explain to you that there is something called as a control limit. Okay, all of you type CL in the chat box. These are some takeaways today. Okay. You have to write USL, you have to write LSL, you have to write CL, control limit. Okay. And you can also type UCL and LCL, upper control limit and lower control limit. Upper control limit and lower control limit. Now, so these are the words that you have learned today. Specification limits ESL. Under specification limits, you have upper specification limit, lower specification limit, under control limit, upper control limit and lower control limit. And remember, specification limit decided by customer, SL is decided by customer, CL is decided by the process data. Okay, so please write in your notebook, SL, which is specification limit, is decided by the customer, and CL, which is control limit, is decided by the process. Okay, with that said, we will go into what is IMR chart. IMR charts provides variation over time in a graphical method, and a graphical IMR helps identify when it goes out of control limit. Okay, so even if you are here for the first time, all of you, what I request you is just hang on, okay, and try to absorb the contents, whatever it is, because these are all standalone contents and very, very important for application in your organization. Okay. So you can see here, you can see in this graph that there is an upper control limit and lower control limit. And you see that the data is plotted, individual value is plotted on the top. So all of you type IV in the chat box for individual value. All of you type MR in the chat box for moving range. And if you want both the charts put together, it is called I-MR, individual moving range chart. So individual points are plotted and the range is plotted, and the range has got a control limit. The individual values have got a control limit, and this is. Thank you for your active response. I want active response in the chat box. I will open the chat box, close the chat box, so that, you know, when you see so many people typing, it subconsciously goes deep into your memory, because so many times you're seeing the same stuff and it'll go deep in the memory. And at the same time, if I want you to, you know, pay attention to what I'm saying, I'll disable the chat box. Okay. Now, there are red lines that you see. These are all called control limits. We have not put the specification limit here. IMR chart is just showing the control limits because we wanted to see whether the operation, whatever product that we are producing, whatever parameter that we are measuring, whether it is under statistical control or not. But how do you calculate this upper control limit and lower control limit is what we will see today. Okay, so it is used to check the assignable causes. So there are two types of causes. One is called as common causes. One is called as assignable causes. All of you type CC, and common cause is CC. AC is assignable cause. CC and AC, common cause and assignable cause. Now we've already, this is also called common. Assignable cause is also called special cause. Common cause is also called as normal cause. Okay. Now, last time we gave the example that for assignable causes, if you are late today, maybe traffic is quite common here, so traffic has become a common cause. Okay, and so many other things, you took little late in the bathroom and little late in eating food, and the breakfast came a little late. All these are common cause. A special cause might be if there is an accident on the road. That is a special cause or an assignable cause. If this is clear, common cause and special cause is clear, give me a 9 or 10 if you are super clear. Okay, because this is very fundamental to learn. Because when you put the individual moving range chart, okay, when you put the individual moving range chart, okay, I see some comments that, I'm trying to understand everything since I'm new to this one. It's difficult. Okay, don't worry. All of you all of us who joined here also, came like this. Just to focus on what I'm saying. Even if you get 5% or 10% out of what I'm sharing, it is good learning. How many of you agree with me? Type agree. And if you super agree with me, type essay, super agree with me. Because it's like, this is the beginning of your journey. Okay, this is the beginning of the journey. So what you can absorb like a sponge. Be like a sponge. Okay, squeeze whatever you already have. Okay, and then now try to absorb whatever that I'm teaching. Whatever you can suck in, you can suck in. Even if it is at the surface level, it's still okay. Okay, let me pause the chat because somebody was repeatedly asking this, so I thought I'll break and ask. Otherwise, generally, I don't respond to some questions because it distracts my flow. Okay, I hope you appreciate that. Okay, thank you very much for your understanding. And so, understanding assignable causes or special causes and common causes is important. And when the individual values are within the control limit, still they are varying, and that variation is caused by common causes. But if it goes outside the red line, which is a control limit, then it is an assignable cause. How many of you understood what I said? Just type, give me a 9 or 10 if you understood what I said. I'll repeat what I said. Number one, I asked you to understand this assignable special cause and common cause because in the individual moving range chart, you have the upper control limit, you have the lower control limit, which are the two red lines. Okay, I'll tell you how to calculate those red lines. But the point that I want to communicate is if the individual data points are operating within those red lines, then there is common cause of variation. If it goes outside that red line, it is a special cause or an assignable cause. Now, if you are clear, give me a 9 or 10. If you're still not clear, watch the video. If you're still not clear, Google it, ChatGPT. Make sure that you understand that, okay? Good. I think most of you are giving me 10 on 10 to monitor the process performance before and after implementation of the improvement. So if you've done the improvement, you can say that, okay, my variation was within this band, and after improvement, now it has improved to this extent, and you can show a different brand. So that is also one of the use. Okay. So individual, this is when the production rate is slow and difficult when you don't have many samples. Okay, individual moving range chart is very useful because sometimes there is huge production. Okay, that time we will use an X bar R chart. But when the production is slow, we have little samples, use individual moving range. So individual moving range used for two particular situations. One is if the production rate is very slow. Second is if it is a destructive testing, because you cannot destroy large, like for example, pressure tester, rupture tester, tensile stress, and all that. Okay, destructive testing. Yeah. All right. So if the uses for individual moving range chart is clear, type SC, super clear in the chat box. Okay. So whenever you have the IMR chart and X bar R chart, if there is a large sample, okay, thank you very much. If there is a large sample and when you have, actually we'll do, when I explain the X bar R chart, I'll explain the concept of subgrouping, rational subgrouping and all that. As of now, we will stick on to when the subgroup size is 1. There's only one value that we are taking, and that individual value we put on the plot. This is called as, then we use individual moving range plot. It is also called XMR. X is the data point, X1, X2, X3, X4. So don't confuse with X bar R chart. This is, some people in some books, IMR is also called XMR. I is an individual, and that individual is the X, okay, X1, X2, X3. So some books refer it to as XMR chart also. Okay. So the sampling method, if you see here for this IMR chart, is I'm going to give you an Excel sheet where I'm going to share with you all the formula on how we are going to exactly calculate this. Okay. So it's simple systematic sampling plan method, and in this sampling plan method, we take a single piece at a regular interval point, and you can refer to the below examples. Okay. I will share this data also so that, and the Excel sheet also, so that you can see that clearly. Like one sample in the day, one sample in the shift, one sample in the week. You can just plot the individual values like this. Okay. So 3 fundamental uses: monitoring the process stability, okay, identifying the stability in the process, identifying whatever is causing the issues, and showing the improved performance. So these are the 3 main reasons. One is you can monitor the process stability, and you can identify the causes, assignable causes, and third is you can also show the improved performance. These are the major uses of the IMR chart. Okay, fine. Now, this I chart is something plotted like this. Below is the example of the I chart for the individual values. In this example, the sample is pulled once in a day. Okay. And since the data is not obtained very frequently, an individual control chart was selected. Okay. Always remember this. When the data is not quite frequently possible, then use the individual. So on the first day, the test method indicated that there was 105 ppm of the contaminated in the product stream. Okay, fine. Let's not get detail into this, but all you understand is there is an upper control limit or lower control limit, and the data is varying somewhere in between this. Okay. Okay, moving range. Moving range is something interesting. The below graph is a moving range of what goes with the X chart. X chart or individual chart. Okay, don't confuse between X and individual. It's used interchangeably. Okay. Now, when there are different data points, I'm going to share with you Excel sheet. Okay, let me reveal that Excel sheet to you. Okay, it is there in Safari here. Okay, there is an individual, the wait time. For example, there is a trip, there is a wait time. I'll share with you this link. Okay, I'll share with you the link. But all I want to show you is, I want you to focus only on these 2 rows now. Don't confuse with anything in any other part of the sheet. Okay, so there are 24 data points, and there is the waiting time of each trip. Okay, there are 24 trips, and there is a waiting time of the trucks or whatever it is in each of these trips. So here, if you see 3.5 minutes, 2.5 minutes, 4.1 minutes, and it is varying to some extent. So we have 24 data points. So for the sake of, okay, can I really hide it? No, I can't hide it here. What I'll do is try to open that in that editable version and try to hide it and then reveal it to you later. Okay, let me check here. Let me share the screen quickly on this. Okay, now for the benefit of the focus, I will, as of now, hide this. Okay, where is the hide? Okay, I'll hide this, and I will also hide. I'm sorry, I think I am not able to hide because this is the image that I pasted here. I will hide the remaining portion of it. Okay, I'll hide the remaining portion here just to avoid confusion to you. Okay, I've just hidden this. So I have just kept these two areas of focus so that you can quite focus on this. Okay. Now, if you see here, if my screen is clear, if the data is clear, just type super clear in the chat box. Okay. I want to make sure that the data is clear here. So the data is like this. There are 20, let's say a truck coming and there is a waiting time for the truck. We wanted to reduce the waiting time of the truck. Okay. And there is a trip 1, trip 2, trip 3, up to 24 trips. And there are different waiting times. Okay. Thank you very much. Now, this is something that we wanted to plot the individual data points. Now, what we have done is, let me bring your focus back to this sheet. Okay. Now, if you actually see the moving range here, I wanted to explain the moving range here. Of all this, I've calculated something called as an average. This is simple. This is called X bar. Okay. And then I have calculated something called as moving range. Okay. How do I calculate the moving range? Let me hide other things just to make sure that you don't get distracted. Okay. Now, one thing very, very important to note, all of you write down, this particular thing, I have used the formula E4 into, I'll reveal the formula to you. Okay, data, I think, show formula, right? View show formulas, okay? So if you see the formulas here, I'm showing the formula. I hope all of you are able to see the formula, right? Type yes in the chat box if you're able to see the formula. Okay, good. Okay, let me quickly pause the chat here. Okay, now in the formula, if you see, if I see this is this minus this. Okay, so if you have 24 data points, you will have 23 for moving range, because the first data point is the difference of second and first. So x2 minus x1. This is x2 minus x1. This is x3 minus x2. This is x4 minus x3. This is x5 minus x4, and so on and so forth. If you are clear, please give me a 9 or 10 if you are super clear. It is just the difference between two data points. Okay. Good. If that is clear to all of you, one thing very, very important to plot, you have to, okay, let me show. I have put absolute of F4. That is absolute of this number. Why absolute of this number is something you have to note down. Okay. Let me view of the formulas. Okay. We always want a positive number here. Okay. For the moving range. We always have that. So I put absolute. For example, 2.4 minus 3.5, it is minus 1.1. But I have given you the positive 1.1. 4.1 minus 2.4 is 1.7. It remains as 1.7. So negative values, put absolute, big positive, and then calculate the moving range average. Okay. If this is clear, please give me a 9 or 10. If it is super clear, because otherwise, all of them are simple mathematics. Okay, these are the things that you should remember. Otherwise, all of them are simple. Okay, these are the things that you should not make mistaken. Thank you very much. Okay. Okay. Now, if that is done, then we are ready to plot. Now, I will share with you this particular sheet. Okay. How many of you want this Excel sheet? Just type want in the chat box. Okay, please, you are lost. Okay, you have Bernard, you have two options if you're lost. Okay, you can stay focused and try to understand and then catch up. Or probably, if you cannot, if you feel you catch up, good luck, you can take your decision. That's okay. Okay, right. So let me share this link with you. Let me copy this link and then put it here. Okay, this is the link that I'm sharing. Okay. Okay, you might face some issues. Some people might face issues of not opening because Google Sheet will suddenly think so many collaborators and then it will start hanging. Okay, so if you're facing some issues, You need to wait for it to load. Okay. Okay. Now that you have done this, let me go back, take your attention back here. This is the moving range, and that is what is plotted here. This chart represents the range between successive data points. Okay. The range value is plotted for the second day is simply the range between day 1 and day 2. And then the range is often called as a moving average. So this range is 105 minus 93, something like this, 12. Okay. So the steps: first to gather the data, plot the data. First to gather the data, we have 24 data points, then plot the data, and then calculate the overall process averages and control limits. So now interpret both the charts and control limit and calculate the process standard deviation, whatever is appropriate. Okay. So gather the data. Now what I'll do is, just 1 second, let me share with you directly the example what we have so that we, okay, so I have to explain this, sorry. I have to explain this. Let me quickly explain this to you. Okay, in gathering the data, select the frequency with which data will be collected. Okay, data should be collected in order in which it is generated. Then select the number of data points, and then control limits will be calculated after you collected 100 data points. Okay, record the individual sample. I'll give you an example how to do that. Now, we have already seen that the moving range, for example, calculate the moving range, that is the second minus first, the third minus second, and so on and so forth. Okay. And I'll share this presentation. And the important thing is I've already explained that the range should always be positive. Okay. Then plot the data, x-axis, y-axis for both x and r bar chart, plot the ranges, and then individual. Now, this is what is important. I want you to pay attention. I've just rushed through this because the previous 2 steps are very easy. I want to rush through this. I wanted to calculate this, explain this, because you have to calculate the moving range. And the moving range is nothing but the average of all the ranges that you have done. And in the Excel sheet, if you see here, it is simply the average of all the data points here. That's what is explained in this PowerPoint also. So you need not worry about this formula that is there, because when I was doing college, this summation itself scares me. Okay. This is also called, summation is also called bigger sigma. Okay. Okay. Moving range is calculated the difference between multiple collected data points. Now, most important thing is we use 2 constants called D4 and D3. Okay. Now, I wanted to take your attention to a formula here. There are 2 constants that is used in the formula. One is called as a D4 and D3. Okay. So let me also zoom it a bit so that you can see the bigger. Now, subgroup size n is equal to 2 or 1. Okay, n is equal to 2 or 1. Now, there are 2 interpretations. People say n is equal to 1 for individuals, and they say n is equal to 2 because for the moving range, you have 2 data points, right? But nevertheless, this is the D4 is equal to 3.267 and D2 is equal to 1.128. These are the constants that we'll use in the formula. So if you see here, the way that you calculate this moving range is like this. First of all, average moving range formula we have done here. Okay. Let me reveal the entire thing to you. So for your benefit, I put the D4 here. I put the D3 here. I put the data points in these 2 rows. Okay. So I can also, what I can do is I can highlight this so that you know this is a data point. Okay, data points are there in the green and constants are put in this 2 places. Okay, the constants are put here. Now I have moving range I have calculated here. Okay, now the average of the moving range, what you got here as, let's say I'll darken it here, and average of the X bar, I'll also darken it here. Okay, and I've also put it in individual columns. The reason I put it in individual columns is, if you see the formula for the upper control limit, it is X bar plus E2 into R bar, moving range bar. Okay. Now, E2 is also a constant. E2 is 2.66. Okay, so three constants are used here, D4, D3, and E2. Please type it in the chat box. This is the only important thing you'll have to remember here. There are three constants that is used, D3, D4, and E2. All of you type D3, D4, and E2. So where does it come from? Very good question, Dan Felix. The statisticians have done a research and found that, established a theorem and proof that for calculating the control limits, depending upon the subgroup size, you use these constants. Why do they use this? It is like you don't have to worry about how they have derived it. All that we'll have to do is we'll have to consume it. Okay, for example, can you all see my screen? Type yes in the chat box. For example, we all know Pythagoras theorem, okay? A squared plus, in a right angle triangle, on the two sides, A and B, the hypotenuse C is C squared is equal to A squared plus B squared. How many of you know this? Type K, no W. Pythagoras theorem. But how did this come? They have established. You can try and check it. Similarly, there are a lot of mathematical, particularly in Six Sigma, okay? There is a lot of test that is there. All you have to do is put that formula. For example, regression we are going to calculate. Correlation we will calculate. How did that come? This is already established. Formulas are established. How many of you know the equation of a line is y is equal to mx plus c? And c is a constant, right? And m is a slope. How did it come? The statisticians are established that. Similarly, so I want to settle this here, okay? I want to settle this here. Similarly, there is a formula for the upper control limit, which is x bar plus E2 into R bar, and lower control limit is x bar E2 minus R bar. So we need to know MR bar, okay? And control limit for upper control limit for moving range is D4 into MR bar, and lower control limit is D3 into MR bar, and D3 is a 0, and so lower control limit will always be 0 for the MR chart. Okay, so for your easier understanding, I have put D4 also here, D3 also here, and I've given the data points here. I've calculated with negative numbers here, I mean the ranges here. I've given the absolute of the ranges here. I've put the MR bar here because for the individual moving range chart, the formula is D4 into M bar, and lower control limit also you can use the formula. This is 0, okay? And then individual values, I've put the center line here also. Center line is nothing but the average of that. And the formulas also, I've put it here. For anybody who has got the basic knowledge of Excel can see all the formulas here. Step by step it is calculated. And then the target is 5 and so on and so forth. Now I have just generated a chart from there. Okay, I've used a simple line charts. Okay, and I made it downloadable. You can download this chart also, and you can go through it, and you can see. And this one is generated from Minitab, and this is generated from Excel. You can see both the charts are same. And again, for the moving range also, one is generated from Excel, one is and also generated from Minitab. Okay, this is a moving range, right? Moving range is generated from Minitab. All right. So there, once again, I wanted to share this particular sheet with you so that you can download. How many of you are able to download this? Type yes in the chat box if you are able to download. If you are able to download, okay. And how many of you can download and understand all this? Type me in the chat box if you can download and understand this. So to summarize, I'll just summarize quickly in a couple of minutes. One is individual moving range charts. Okay, I'll stop sharing and summarize. Individual moving range charts are used when you have few data points, when the production is slow, and when it's sort of destructive testing. You cannot destroy so many components, number one. Number two, individual moving range chart is used to find out the special causes. How do you find out the special causes? You first have to put control limits. How do you find the control limits? You have control limits for individual values. You have control limit for the range. You know how to calculate the range. You know how to calculate the average of the range. You know how to calculate the average of individual samples. And with that numbers, as I have shown you here, there is an upper control limit for the individual values. There is a lower control limit for the individual values. And the formula is given here, which is D4 into R bar and D3 into R bar. I'm just not using moving range bar. You understand that it is a range, okay? So you know the upper control limit and lower control limit. And also upper control limit and lower control limit for the X chart, that is the individual chart, is also like X bar plus E2 into R bar and X bar minus E2 into R bar. Okay. So if this is clear on a scale of 1 to 10, whoever is clear can give me a 9 or 10. Okay. Whoever is clear can give me a 9 or 10. Let me change it for everyone. Yes, you can just open up. So if you find today's session interesting, useful, valuable, fantastic, awesome, okay, so type whatever that you felt about today's session. I really thank you for joining today's session.